Hello and thanks for watching. My name is Kyle Lejeski, District Sales Manager with EMC, and today I want to spend some time talking about literally the Bermuda Triangle of data. It's something that our customers struggle with every day, and I think it's a solution in which EMC's got a pretty good answer to. So I'll kind of start by drawing up really a triangle of information, and within this triangle, oftentimes customers will have a lot of their mission critical kind of current state, or if you want to refer to it as Platform 2 applications like SAP, Oracle, and SQL. In addition, they'll also have applications like File, Object, and Web. And then ultimately they'll have some of their next generation applications like Hadoop, or anything related to big data initiatives, and even mobile. And as you can see, this starts to become a pretty convoluted, triangle of information. And a lot of times we get lost in how we manage it, where we put it, and where we store it. So today I want to kind of start with a very simple three-tiered approach to how EMC addresses this Bermuda Triangle of information and the Bermuda Triangle of data. First and foremost, the fastest way to reduce your storage costs by anywhere between 60 and 80% is to archive 60 to 80% of the stagnant, unaccessed, or not modified data out of the Tier 1 storage environment. It's also the fastest way to speed your backups by 60 or 80%. EMC's got a pretty unique solution in EMC Isilon that provides the ability to do that. Isilon in itself is essentially software-defined scale-out storage for unstructured data sets. The beauty of Isilon is on the front end, I can literally start as small as 10 terabytes and can grow to almost 100 petabytes in a single file system. Very simple, very easy to manage. On the back end, I have a number of nodes. Every node contains compute, network, storage, CPU, and memory. So as I add additional nodes, I add additional network, performance, and capacity to the cluster. This scales from a minimum of 3 nodes up to a theoretical maximum of 144 nodes. A very simple way to address unstructured content. I can access this over a number of different mediums, including CIFS, NFS, Object, HTTP, and even HDFS, or the Hadoop file system. A very flexible, highly extensible platform for unstructured data. In the event that I also replicate this massive reserve of information, I can also move that data out of the backup retention, essentially solving 60 to 80% of my data challenge. With the remaining information, I can now build a high-performance storage tier. I want to build the similar design principles in the storage environment and ultimately the backup environment that I did in my scale-out archive or scale-out NAS environment. So a lot of times I'll draw this bell curve of technology adoption, and I'll align it to the two next mediums here. The first is in production data centers, a majority of our customers are leveraging spinning disk. With the requirement or urge to want to move to flash-based media, the barrier to that being cost. Ultimately, to drive mainstream adoption of flash-based media, we're going to need to have a significant shift in the data services or the data reduction layer to allow that to become possible. We believe pretty firmly we've done this in our XtremIO technology, where XtremIO on the front end is a very simple, easy to use technology that inherently provides really 4 key data services. The first is extreme data protection, or how we address data protection. It's a combination of RAID 5, RAID 6, and RAID 10, featuring the performance, the efficiency, and the resiliency of all of those RAID types in a new RAID that is really built from the ground up for a flash-based architecture. The second is ultimately deduplication. When you look at the duplication in a data set such as a virtual server or virtual desktop, the ability to take all of those images and condense them into a single copy has huge cost savings from dedupe. You look at data sets such as databases, which may not dedupe as well. Compression, being the third data service, is how we ultimately drive efficiency and cost savings there. And lastly is our ability to do writable snapshots, or to take clones of the production environment, write them as unique copies, but literally have zero space for those particular snaps or clones. All these data services typically result in anywhere between a 5-to-1 or 10-to-1 data reduction rate. So 7 terabytes of flash easily looks like 70 terabytes of traditional disk with these data services. And again, the hardware layer is scale out. I add a single X brick and can quickly and easily scale those X bricks increasing CPU, memory, storage, and network as I do so. The last piece of this is really how I protect that remaining 30 to 40% of the data once I've archived it out and I'm now storing that high performance relevant information. And that is essentially where our data domain technology comes into play. Similarly, on this adoption curve, a few years ago, customers had a desire to get off of tape and move to disk-based media in the backup environment. And like the flash curve, the only thing that really was going to enable that to happen across the mainstream is extreme data reduction through some type of inline all-the-time data services, like we see in the XtremIO technology. Except here in data domain, essentially what we have the ability to do is land that data inline all the time. We'll never post-process, we'll never dedupe after the fact. So as you stream the data to the device, it lands on that device in an already deduped format. The second thing that we feature here is really a CPU-centric in-memory architecture, which essentially means we don't power the deduplication in our data domain appliance by the rotation of the spindle, but rather the performance in memory at the CPU and RAM. So what we follow is Moore's law. Every 18 months, compute doubles, and every 18 months, our systems get bigger and better and faster. That goes the same for really all three of these technologies. Lastly, when you start to look at how I want to deploy these technologies, whether it's data domain in the backup realm, XtremIO for the tier 1 high performance storage, or Isilon in my tier 2 file or tier 2 scale out NAS environment, all of my applications can now be serviced, whether they're leveraging high performance data services, archive or big data, or data protection, essentially creating a bridge between some of these platform 2 and platform 3 applications if you read any of the IDC or Gartner white papers on the platform shift we're in. And lastly, the procurement methods are very flexible here. And I kind of use the car analogy. If you're going to use a car for 1 or 2 hours, Zipcar is a great solution. If you're going to keep the car for 3 to 6 months, Zipcar probably wouldn't be cost effective. Renting from Hertz or National or another car rental chain would be probably cost effective. If you're going to keep that car for 36 months and want that car every 3 years, renting a car from Hertz or using a Zipcar also not cost effective. Maybe this is some type of lease. Or if you're going to own the car for 5+ years, obviously you can own the vehicle. You're liking these to a lot of your applications. Maybe from a mobile development or application development, you might need the resources for hours, maybe months. And then for mobile applications that make it, or mainstream applications that make it, or enterprise ERP applications, you may need them for longer periods of time. The beauty is EMC is really the only vendor out here that has a full range of hybrid cloud solutions. The ability to start in the public cloud, have the interoperability to then run that data set in the private cloud and send it back. Unlike the web providers that probably favor more towards the public cloud, they don't really have the interoperability to provide long-term, cost-effective solutions. And unlike maybe the traditional vendors who are still trying to figure out private cloud, they don't necessarily have a great way to drive public cloud workload. In our environment, this is literally, VCHS from the VMware Cloud Hybrid Services to EMC's Enterprise Hybrid Cloud, and then a very robust service provider network to fulfill both on-prem, off-prem, utility, non-utility, per month, per terabyte, whichever flexible model you would like, for whatever duration model makes sense for the application sets. So ultimately, the applications drive this Bermuda Triangle of data. EMC's technologies allow you to harness the challenge of managing both second and third platform information. And then once you select the technologies to go and address the application environment, where and how you deploy them, public, hybrid, or private, are also addressed with EMC's end-to-end strategy. We appreciate your time. Hopefully this was educational on how we can solve both second and third platform workloads on-prem and off-prem with EMC's highly differentiated technology set. Thank you.